Engineering Eng. PDF document of this video is on engineering.com.
Hello guys, I hope you are well. Today I'm switching to a new narration system as of this video. From now on, I want to continue like this. I briefly introduced you to coordinate systems in electromagnetic theory in our previous video. Now, in this video, I want to talk about the transition between these coordinate systems. Guys, there was something I forgot to mention in our previous video. Now I want to say it. What I want to mention is that we found metrics in coordinate systems in previous videos, but I forgot to briefly tell you how to keep them in mind. Let's start with that first. First of all, you know our coordinate systems are x, y, z in Cartesian, rho, phi as in cylindrical, and it consists of r, theta, phi components globally. Now, we know that the metrics of the lengths here are 1, hx, hy, hz, hrho, and hr is already equal to 1. So, how do we keep in mind that hv is rho and h theta is r? I want to say that we keep this in mind as follows, friends. For example, we do this to find that hv is rho. When passing from the Cartesian coordinate system to the cylindrical coordinates, the length component, which is not in the Cartesian coordinate system, but it's not here, but has just arrived in the coordinate system, is also equal to metric of the relevant angle in this system. So, who is our new participant in cylindrical coordinates? Not in the previous coordinate system, rho. Rho here is the angular one, here is equal to metric of phi. Likewise, again, for example, when passing from a cylindrical to a sphere like this, our length component r, which was not in the previous coordinate system, and newly joined to this side, is equal to the metric of the new angle joined to the other side, not in the previous coordinate system. I hope you understand what I mean. If you think about it a little bit, you can understand exactly what I mean. In the same way, you can see that we have to write the h phi metric here again, but I said that is equal to rho. But what I remind you, if you remember in spherical coordinates, I drew a right triangle for you in the coordinate system. This was theta, and here was the angle that z made with the theta. One of the perpendicular coordinate system elements was making an angle up to r theta with z, and you remember the opposite side was actually the ground. In other words, the reflection of the floor to upper side was rho. When the hypotenuse was r and the angle in between was theta, the opposite side would give the sin. So you can find yourself that r sin equals theta. The thing to keep in mind is this: how you can remember the method of memorization in the form of any participant, which is not the previous coordinate system, so this is not a very complex method. Normally I am against memorizing, but frankly I am not against memorizing in order to keep our work easy and short once I understand its logic. But it's always important for me to create a logic while memorizing. My advice to you is that we keep this triangle in mind here too. Of course, we all know that they all have a logic. We know that we created a vertical coordinate system from here to z here. If you remember that here was rho, here was theta, here z, here was r. I transferred that right triangle here. We can keep it on our minds this way, friends. In our next video, we talk about the relationship of the cardinal system with each other from EX to EY, EZ and from here to E rho, EP, EZ. Later, I will explain how we move from E rho, EP, EZ to ER, E theta, EV. Hope to see you in the next video. Goodbye for now.